Bismillahirrahmanirrahim. In today's lecture, we are going to look at arrays and the final keyword with the variables. Let's move on. When you might have heard of data structures, when we need to create a bigger structure of data, array is the simplest example of a data structure. In this program, we're going to show you the args array in the main program, which we have been using from the day one, but we never talked about this. Wherever you see the square brackets are the indication of an array. So args is the name of an array. So in this program, if we say how many identifiers we have talked about the identifiers previously. These are not the keywords, but these are identifiers, and it is created and written as per the rules. It should not be a keyword, there should not be a space in between, and it should not start with a numeric letter. So there are three identifiers in this program: the name of the class, the name of the method, and the name of this argument, args. We can name the class ABC, we can name the method anything we like, but the main method is the special method from where the execution of an application starts. So we want this program, an application, so we want to keep a main method. So the main method is a special purpose method, but still this main is not the keyword. This is just an identifier. In here, args is a identifier. We can name it XYZ, anything we like. So this is actually when we run the program at the runtime, we need to pass arguments to the program. When we run the program from the environment where we are actually running the program, from the environment we pass the arguments into the program, and that is gone into this array, and then we are using those values passed here and displayed those values here. Now we are going to show you the way how this is done. We'll do that in NetBeans, and we'll do that in the command prompt, and you will learn a new way of compiling and running a program from the command prompt, which we did not do before. So let's go to the NetBeans. In the NetBeans, we got this small program. In this program, the program says number of words in your name, and it prints the count of the or the length of the array, and then it prints the values one by one. So how do we set the value? We go to run. In here we set the project configuration in the customize, and here in the arguments here I pass three values: Asim, Ahmed, Bhatt. So there are three strings separated by a space. So a space is actually a string terminator. So there are three strings actually being passed in to the program. So if I run the program in the NetBeans, I need to write this package statement. When I run the program here, it will actually accept the three values set in the arguments window, which you just saw. We pass three strings: Asim, Ahmed, Bhatt. So it tells me the number of string passed in, the size of the array args, and then the first value, the second value, and the third value. Now let's take a look at the program in another way. Okay, for easy execution in the command prompt, we just comment this package statement. We come to the command statement. You can see the path here. The path should be the path where we have the application stored. Here we compile the program first, java c arrays.java. We compile it. The compilation is successful. After the compilation, a class file, this is the code file, the Java code, and this is the byte code. The class file is created. Then we run the class file by saying Java command. Here we use Java C command. So this is the different program. Java is a different program. This is the compiler, and this is the JVM, or you can say the interpreter. Java arrays the name program, and then three strings like we passed through the net means. Now when we execute the program, it produces the same output. So you can see how we pass the arguments from the environment, from the CLI, in the CLI interface, and in the GUI interface both. Coming back to the lecture. Okay, in the lecture, we have seen these two ways of passing the arguments to the program. The arguments are passed into the string. So you can see here that when we execute a program from the system, it accepts the argument. This may be passed by the user, or this may be taken from the system. For example, when you double click a program on the desktop, an icon is shown on the desktop. Either you can pass the arguments yourself, or it can get the argument from the system. For example, when you double click a Word doc file, something docx, so when you double click on this, it goes to the system in the registry and look for the application which is registered for this particular file extension dot docx, get the file and load the document into the application. So it opens up the Microsoft Word, whose path is in the Microsoft Windows registry, and it gets the information from the system, and it loads the Word program, and then loads the document into the program. So this is how the communication happens. So in Java, how the environment can pass the values into the program, that we have seen through example. Now, this is the first program where we see the use of array. Now let's go to the next slide and see the concept of the array. What is an array? Array, when we say data structure, it is the simplest way to structure the data. As you can see here, you can see this diagram. In this diagram, we have got a continuous memory allocation of numeric type, and how many values there are? Altogether, there are 12 values. They are stored in the consecutive memory areas, and the address of the name of the memory, the name of the array is C, and the address is actually accessed by the index in the square brackets. So this is the 0 index, 1 index, 2 index, and so on. Java is a language where when you create the array, the first location of the array element is at index 0, and the last element is at index -1. So if not the index -1, the length -1. So index 0 up to index 11, the length of the array is 12. So how do we actually do this? So we create an array, and in the array, the subscripts, which is also known as index, is a position value in the square bracket. It has to be a numeric integer value. It can't be in fraction, must be integer, either a number straight away, or a variable value, or some addition of the variables that can add to an valid index value. So the 0 to 11 are the valid index values. If we try to give any other value, for example -1, this is wrong. Their error will be generated. Or if we try to say value 12, error will be generated. So data structure is a way, because we talked about the primitive data type. In Java, there are 8 primitive types. Others are user defined. But many times in programming languages, we need to collect existing primitive and non-primitive data types together and make it a bigger structure. So that is known as data structure. So array is pre-built data structure. The only constraint and the limitation on the array is that all the data values stored in an array are of the same type, which is the type of the array. So when we declare an array of one type, all the values stored in that array will be of that type. So data structure, related data types are of all the same type. the size of the data structure is fixed, static. When we create an array, it is created with a fixed size. It cannot vary. It cannot be 10, cannot be 15. Yeah, we can make a new array and copy the data from the existing array into the new array. That we can do that. But existing array cannot allow the change of the size. Okay, so c dot length, if we make an array c dot length will give us the length of the array, which is the 12. Okay, let's move on to the next slide. In here we look at how we actually declare the array and how the memory is allocated. To declare array, we can say int c square brackets. By putting the square brackets, we can say this is not a normal variable. This is the array type variable. The type of the array is int, is equal to new int. We have seen the use of new keyword once before when we use the scanner, when we created a scanner object to read input from the CLI interface in our previous lectures. So we create an array of size 12. We can either do this in one line or we can do that in two lines. So in the one line, we can declare the array. In the other line, we can allocate the memory for the array. So every member is of int type. Int type is going to take 4 bytes. 4 times 12 is 48 bytes for this array. The memory 48 bytes will be allocated for this array. Similarly, as you can see here, this is an array of primitive type int. This is an array of non-primitive type or user defined type. So array can be of primitive and non-primitive both. So declaring the array is simple. Allocating the array. Now coming to the initialization of the array. How can we initialize the array? And then manipulating the array elements. So to initialize the array, we can do this. Either we create an array like this and make a program statement for loop. In the for loop, we run the loop 12 times, and for each iteration, we go to one location and place a value. This is manual. This is by programming. Or we can initialize the array like this. So this, by writing this line, the array of 1, 2, 3, 4, 5 values will be created. So by writing this line, 3 things happens. The array declaration, the memory allocation, and the initialization all are happening in one statement. Here we can see here 2 things are happening in one statement. 2 things are happening in different statement. One thing is not happening here. That is the initialization of the array. If we want to initialize the array, we can make a for loop and run the loop 12 times, and for each iteration we can add a value into a location in the array. So each int is initialized to 0 by default. This is the default value. So when we create an array, it will get some default values. On allocation, the elements are automatically initialized to 0 for numeric primitive data types, to false for Boolean, and to null for references. So when we declare an array, it gets initialized by the default values. Okay, let's move on. Multiple subscripted arrays. What are multiple subscripted arrays? When we want to create an array with more than one dimension. For example, there is an array of 3 rows and 4 columns. So the size of the array is 3 by 4. We can make an array of this sort which can store values in consecutive areas in rows and in column. As we know in our daily life, we have to create some data structure, or we have to represent the data structure in the form of a tabular form on the screen, and we need to store the data accordingly. So there an array of 2-dimensional or multiple dimensional can be useful. So multiple subscripted arrays can have rows and columns. So here is an example of a 2 by 2 array, 2 by 3 array, and the initialization are happening. So this element is at location B00. 00 means 0 row, 0 column. So B01, 0 row, first column. B10, B11. Okay, Java does not support multiple subscripted arrays directly, but allows programmers to specify single subscripted arrays whose elements are also single subscripted arrays, arrays of arrays. What does that mean? That means we can make an array of variable sizes. We can make an array where there can be some, this is not a grid like this. For example, we can make an array of first row having 4 columns, an array of second row having 2 columns, an array of third row 3 columns. In many languages this is not possible. If you try to do that in many languages, you have to keep the other cells unused but allocated in the memory. So that means the memory is wasted. In Java this is not the way. In Java we can have a array of different variable size of columns and without wasting any memory. So this is statically and this is dynamically. What is the meaning of dynamically? Dynamically means when this statement runs, then the actual allocation happens. When the new statement runs, this runs at the runtime, then the new allocation happens. Okay. Rows can have different number of columns. We have talked about this, that direct multiple subscripted arrays are not possible. So this is what it means, that we create an array where we say B is equal to new int 2. So this allocates rows B0. The first one is going to have 5 cells and B1 is going to have 3 cells. Okay. If we make a statement like this, in this, the B is a single subscripted array and C is double subscripted array. The first is here, the second is here. So B is a uni and C is a bidirectional array. Okay, this is the introduction of the array. Array is a very useful technique to structure data. One thing we haven't talked about, and that is the final keyword. If we place the final word with a variable, for example, I say in my program, instead of int, I say final int x, then the final is actually making the int x a constant. So in Java, we use the keyword final for the constant purpose. Constant, we know, has a value which is not changed throughout the program. So we can only assign a value at the time of declaration. At the time of declaration, when I say constant final int x, at the time of declaration, I have to assign a value. After that, I cannot assign the value. For example, if I say final int x is equal to 5, this is good, this is okay. If I say 5, x is equal to, let's say 6, now this is not allowed, because we can only assign a value to a constant or a final variable. Constant is a concept, but in Java the keyword is final. So by saying final, x becomes constant. The constant can be given a value only at the time of declaration. It cannot be given any value afterward. So we delete this here, or we can keep it written for later purpose. We comment out. Okay, this is the introduction of the array and the final keyword. We stop the lecture here and take care until next time.